This paper and this poster introduce the LEAFTOP dataset, which is a new large database of nouns across 1,480 different languages. Those languages cover roughly 80% of the world's population's native tongues. We use a fairly naive approach, which is just simply statistical modeling, to take a Koine Greek New Testament and then match that up with translations of the four Gospels of the New Testament of the Bible into the languages that the Bible has been translated into. This gives us about 160 nouns in both singular and plural forms. And the resulting data set is useful for all sorts of things like grammar morphology problems, looking at language similarity, and just exploring language families. Moving to the top left of the poster, we chose to use the Codex Sinaiticus. Now, the Codex Sinaiticus is the second best Koine Greek source for the New Testament. But it's the easiest to do linguistics on because the wonderful people at OpenText have gone through every word in the New Testament and annotated it with this word, what its Greek lemma is, the case and number and gender of the noun, and put the whole thing into a very simple XML database that's very easy to parse. And so from that, when we parse these XML documents, we can then work out that there's 188 nouns that are repeated in both the singular and plural in the four Gospels. And we chose the four Gospels because the expectation was that they're written just narrative form about events that made sense in an agricultural society. And so we're hoping that would be kind of universal. It turned out that we had some problems with this. So, for example, Gunwingu, which is an Australian Aboriginal language of a population that are historically nomadic, they didn't have quite a lot of words here, like prison or governor were untranslated, and they just used the English, which meant that we got incredibly good accuracy on Gunwingu when we weren't really succeeding there. But anyway, taking the 3 and a bit thousand verses in the four Gospels, which have some noun in them, we can then narrow it down to the 2 and a bit thousand verses that have one of these repeated lemmas. Then we look at the 2,000 and a bit Bible versions that exist and narrow that down in that when we tried to scrape the Gospels from each of these Bible versions, sometimes things didn't work out. So, for example, there are Bible versions where there's a translation and they have never got around to completing the translation of the Gospels. They just did the Psalms or Proverbs or something like that. So it's a distinct Bible translation but not a complete one. So we had to leave those out. Also, there were Bible versions where there was large chunks missing or several verses missing, and we'd leave them out as well. But we made exceptions for things like the last bit of John chapter 7 and the beginning of John chapter 8, which is not a passage that's universally accepted as being part of the original Gospels. So if a translation doesn't include that, then we still kept it in anyway. The end result of that was 1,480 languages. So that meant that we had to scrape 6 million and a bit verses off the web. And that was very fortunate that the HiQ versus LinkedIn Supreme Court case finished when it did, because it gave us validation that this was a legitimate thing to do. That scraping process took several weeks. And then afterwards, we then took the lemmas that we knew from each verse, and all 188 noun lemmas, and then applied the binomial test for each lemma, against each of these target languages, and that was another 26,000 CPU hours done in parallel on a large AWS machine. As it turns out, we can't get all 188 repeated noun lemmas. And generally, we found in most languages around 160 to 161, because the other 20 or so noun lemmas only appeared in a very small number of places, or they were always in co-occurrence with some other word, so we had no way of being able to distinguish them. And the end result is that we were able to get 239,156 words of vocabulary spread across 1,480 languages. So let's look at an example of how the World English Bible translates the word menemeon. Now, menemeon only appears in the Codex Sinaiticus in the nominative singular form in John chapter 19, verse 41, and then the following verse 42. In the paper, we've got an algorithm that can distinguish between languages like English that are alphabetic and have word break markers, and languages like Chinese that are non-alphabetic, and languages like Thai or Khmer, which are alphabetic but don't have word break markers. And because of the small number of Unicode points that we see and the success of identifying a word break marker, English is identified as alphabetic. And so therefore what we'll take is each unigram from John chapter 19, 31 and 42, and see of those 35 unigrams, which one of these seems to be the most likely to be the right translation. Now, we don't want to spoil our binomial test by including verses that have menemeon in some other number or case. So we restrict it down to getting a baseline probability of how often does menemeon appear in the nominative singular in verses, and how many verses does it not appear at all, and then we'll look at how often each of these unigrams, like the word tomb, for example, appear. And also we have to leave out verses that we're unable to scrape for some reason. And so that leaves us in this case with 2,831 verses. The English word tomb appears in 6 of them, laid appears in 29 of them, garden appears in 4 of them. And so you can come up with these baseline probabilities of a lemma appearing. So typically in English language, our model says about 0.68 of all verses have the word the. Roughly 2.2 times 10 to the minus 3 of them have the word tomb, at least in the 4 Gospels. So then we count the number of times that the word tomb appears in each of these verses where the nominative singular appears, and we come up with tomb and laid appears twice and garden appears once. And so then we can do a binomial test on the result. So our baseline probability of 2.2 times 10 to the minus 3 for success, and we succeeded twice at finding tomb in the 2 verses we were expecting to find it. What's the probability that that would actually happen by chance? And of course that works out to being 4.5 times 10 to the minus 6, a really unlikely thing to be happening by chance. And when we do that with all the different lemmas, we conclude that tomb is the one that's most unlikely to appear just by chance, so therefore we assume that that's the right translation. And indeed, we're correct. That is the right way to translate menemeon into English. We can then get a confidence score where we take the winner of that competition, which is tomb, and we take a log of it and divide by the log of the p-value of the runner-up. And that gives us a confidence value of 1.3. And it's a sense of saying, how sure are we that that is going to be the right answer? One of the challenges, of course, in having a 1,480 language lexiconary is that most of the languages in the lexiconary are ones that neither Diego or myself speak. So how do we evaluate it? We couldn't just randomly sample languages from this data set, because that will almost definitely land on some language that is spoken by a very small number of people and no translator was available. So we went with the approach of breaking it down by language family, and then within each language family, finding some translators for that family. That slightly biases us towards some of the more popular languages, but we've still managed to get a decent spread. The one area that we really struggled on was finding translators from Native American languages. There's a little note above me here about if you can help with that, that would be much appreciated. And Australian Aboriginal languages, we only managed to find one translator to check our work there. What I find most interesting about this chart here, the proportion correct, is that it wasn't actually the Indo-European languages where we had the greatest accuracy, which is what you'd expect when we're coming from Koine Greek. When we took the data that we collected from the translators, we saw that certain words, like straight above me, words like bread and hand and God and prophet, they were almost always extracted correctly, as you would expect. But then there were also words like grapes and fullness and beginning and poison, where the extraction algorithm was actually getting it wrong more often than it was getting it right. When we plotted that against the confidence score here, we could see that there is a relationship. It's not as strong a relationship as we really wanted, but it does show that generally speaking, as the confidence goes up, so does the likelihood that the translation is correct. And so we can then use that in this chart over here, where you can set a threshold and say, I have a minimum proportion of vocabulary that needs to be correct, and I'm willing to shrink the size of the vocabulary. And if you use the confidence score as your threshold, you can make those trade-offs, and those trade-offs generally work reasonably well. We identified 3 fun use cases for the data from the LEAFTOP dataset. The first is exploring similarity between languages. The idea here is a very simplified model that says if 2 languages are similar to each other, then translators would encounter problems translating words from Greek into those languages in similar ways. So if we take the confidence scores for each lemma in the 2 languages, we can get a correlation statistic. And if we then, I'll just switch over to the graphical version of this. If we then make a force-directed graph that pulls languages together if their correlation scores are strong, and then just focuses on a region, you'll see that it actually kind of works. We do see that the Austronesian languages all sort of pull together, and groups of related languages in related areas do seem to connect. This is also true if we go over to languages in the vicinity of Swahili, for example. You'll see that it detects that Luganda and Swahili are obviously somehow related. You'll also notice that there's quite a few places where it gets it wrong. A lot of the European languages end up being correlated. What we tend to see is it's the languages of the people who were doing the colonizing and doing the missional work. So, for example, Portuguese and Spanish keep cropping up as being highly correlated. The second use case is it's just a very large lexicon of vocabulary, and since we have singulars and plurals, we can do large-scale grammar morphology tasks. Can we deduce the correct plural form from a singular form in many of these languages that nobody has ever worked with before? Finally, the use cases I move out of the way here is we can also identify which Bible translations are paraphrases versus literal. So the message here from Eugene Peterson, which he happily admits is a paraphrase. If you look at the confidence scores, the median confidence score of all the lemmas translated, it's much, much lower than, for example, for Young's literal translation, where he was trying to match the Greek very closely. And we were unable to translate many of the lexicons, so that many of the lemmas, they just didn't come out. The entire dataset for LEAFTOP is available on GitHub, as you can see above me, as well as the source code for creating it. So do take the opportunity to fork the repo and use it in your research if that's something that is helpful to you. I'd also like to take this opportunity to thank the many translators for their fine work in assessing the LEAFTOP dataset. It would not be what it is without you, and thank you very much.